Hello and welcome to another exam paper walkthrough. Today we're doing a slightly different pitch. We're doing a GCSE Maths June 24 paper 2 practice or preparation paper. This is taken from Good Chance Topics from First Class Maths. They did an excellent exam paper analysis and they've come up with their topic lists. So this paper has been produced using that as a source material. Hope you find this video useful. I would recommend get some music on in the background, and if it's useful, please do subscribe if you like. Right, before we really get started, attached to the description to this video, you will find the link to a Google Drive where you can access a copy of this paper. If you've not already got a copy, I would strongly recommend that you try the questions either before or alongside the video, just to get the most out of it. So like I said in the introduction, this is a Good Chance Topics, so please check out my other video. So First Class Maths have done a paper 1 analysis and come up with these as their key topics. So I've done 2 videos for the higher paper, one based on just their highly likely topics and one this paper which is based on good chance topics. So I would recommend doing both the papers, but maybe concentrate on the highly likely so you've mastered those, and then maybe move on to this one if you've not already. Okay, so as always, there's no guarantee that these topics will come up. This is just a forecast based on the analysis of past series and questions that appeared on paper 1. There are a few questions on both of these 2 papers as they have an overlap in skills tested. Following on from that, what I've done is I've used Edexcel's GCSE higher tier enhanced skills mapping grid to select my questions, and then what I've done is I've arranged them by mean difficulty. So I've found all the questions that matched. I've tried to use common questions, and then once I had those all selected, I've just done a ranking in terms of mean percentage difficulty. And that's how this paper has been produced. And without any further ado, I shall crack on with question 1. Right, so question 1. Hannah is planning a trip for 195 students. She wants a sample of 30 students. She asks a sample of 30 students where they want to go. Each student's choice chooses one place. The table shows information about her results. Work out how many of the 198 students you think will want to go to the theme park. So in effect, what we're doing is we're treating this as a proportion. So 10 students at the theme park. Let me just, I like writing in red or blue? Blue. So 10. So we want, so we're saying in effect 10 out of the 30 students would like to go to the theme park, and we're going to times that by 195. That's obviously going to be 1/3, but no real need to simplify that because it's calculator paper. So we use a calculator as much as we feel we need. So 65. So on my answer line, I'll also enter 65. State 1 assumptions you made and explain how this may affect your answer. So the assumption that I've made is that the sample is representative. That her sample is representative of whole group. If it's not, my answer may be wrong. And just as an example of that, let's say planning, if she asked, not the greatest example, but let's say if she asked her sample outside of, if she just asked her friends, or if she just asked a group who'd recently been to a theme park, there may be a skew or biased towards theme park. Right, question 2. Last year, a family recycled 800 kilograms of household waste. 57% of the waste was paper and glass. The weight of paper recycled to the weight of glass recycled was 12 to 7. Calculate the weight of glass that the family recycled. So I'm going to just clear this information up into something that I'm happy at working with. So we've got paper to glass in the ratio of 12 to 7. Okay, so this ratio is only 57% of the total ratio. So we first of all we want to work out how much that would be. So I'm going to do 0.57 times by 800, and that'll give me the actual weight. So they're splitting 456 kilograms into this ratio. This ratio has got 19 parts, so if we do 456 divided by 19, that'll give us the weight for each part of the ratio. So each part of the ratio is going to be 24, and then we actually want the total weight of glass, so we want 7 times by 24. So we've got 168 kilograms. Is that a unit? We have, yeah. Right, question 3 then. Let me just sort my view out slightly. There we go. So here's a right angle triangle. Calculate the value of x. So we've got a right angle triangle involving 3 sides, so it's automatically going to be Pythag. And we're trying to work out a shorter side, so I would jump straight to this. X squared is equal to the hypotenuse squared minus the other side squared. So I would jump, I mean, let's be fair, we can jump straight to this. So I'll do 8.5 squared, and I've missed my point out, 8.5 squared minus 4 squared, and I want to square root my answer. There we go, so 15 over 2, which is obviously 7.5. And there we go. Completely irrelevant, but we're actually at 7.5 minutes of the video, and the answer for the question was 7.5, quite random. Right, question 4. A number D is rounded to 1 decimal place. The result is 12.7, completely error interval. So that means that it's been rounded to 12.7 as opposed to 12.6 or 12.8. So we look for directly in between, and there's become our kind of our error intervals. So we're looking at 12.65. Let me just clear that up. 12.65, which is the middle of those two values, and 12.75, the middle of those two values. Question 5. One weekend, Keddy's family is going to do a sports quiz and a music quiz. The probability that the family will win the sports quiz is 0.3. The probability that the family will win the music quiz is 0.35. Complete the probability tree diagram. I love these questions. I find them probably one of the most easiest 2 marks on the paper. So we've got one of the probabilities here, so the other one has to be adding up to 1, so 0.7. And over here, we've got to have 0.65 for both of those, and that's my 2 marks. That's my 2 marks. Part B, work out the probability that Keddy's family win both the sports quiz and the music quiz. So that's this branch up here, the top branch. So we need to do 0.3 times by 0.35, which is going to give us 0.3 times by 0.35. So we're looking at, this is my point off there. So 0.105. Question 6. We've got -2 is less than or equal to n, which is less than 5. N is an integer. Write down the greatest value for n. So we can kind of view it on a number line. So it's got to be less than 5. So the integer is going to have to be 4. For the second part, on the number grid below, show the inequality -4 is less than or equal to n, which is less than 1. So we're going to have a circle at -4 and a circle at 1. So let's put our circle and a circle at 1. We need to join it up. I'm not doing that very well. And then we would need to shade in. I kind of view the line as a liquid, and the liquid can be equal to this, so it can go into the bubble. So there we go. And part C, solve. Two-step inequality. I treat these just like equations, to be fair. So I'm going to add 4 to both sides. So 2/5g has to be less than 10. That's adding 4 on both sides. Then in effect, we're going to times by 5 and divide by 2. So g is going to be less than or equal to 25. Question 7, complete the table of values for. So I'm going to use the table function on my calculator. I'm just going to make this a little bit bigger. It's not overly commonly used, but just want to. So I go menu, and then I want this table function, which is function 3. And then I get the option of typing in a function of x. So I type it in as alpha, that's x squared, -2x, so -2 alpha x plus 2. Right, I'll be given the option of entering another function. I don't want to enter a second function, so I just leave that blank, press equals, and then it tells me where do you want to start, where do you want to end, and what steps do you want to go in. Well, my table starts at -2, so I type in -2, and my table ends at 4. And I want to go in steps of 1, so that means that's the jump between numbers. And then it will automatically fill my table in for me, and we can check the two values that are shown, -2 and 10, which correspond to the top row, 0, 2, which corresponds to the third row. So -1 and 5, and then we've got 1 and 1, and then I use the replay button on my calculator just to go down my table to cover my other values. So we went 2 and 2, and then 4 and 10. And you can type each of these in individually if you're not confident or familiar with using the table function. But if you've got time, give it a little practice. It is a useful function. Right, draw the grid. Okay, so I was just trying to work out how I was going to show my table and the graph, so I'm actually going to use my calculator for pulling off the values straight away. So -2 and 10 would be that coordinate there. I've then got -1 and 5, which would be there. 0 and 2. 1 and 1. 2 and 2. 3 and 5, and then 4 and 10 again. Now you want to join them up with as smooth a curve as you can, so I always keep my wrist on the inside if I'm doing this on a paper copy. If I'm using a digital copy like this, I tend to take a cheat. Okay, so my cheat is, all I'm going to do is insert, and the shape I want to insert is going to be a wavy line. So mine will automatically give me a smooth curve. Trying to do it on a digital screen is quite tricky, but like I said, I would always keep my wrist on the inside of a curve. So say I would put my wrist sort of there and sketch it around just to try and get it as smooth as I can. So use your graph to estimate the solution of the equation. So It's always worth double checking. I haven't seen it for a while, but just check that the left hand side of the equation is equal to the original equation. So this is the equation of x squared minus 2x plus 1 plus 2, and in effect we want to compare that to the graph of y is equal to 4. So y is equal to 4 is going to be this line here. So you draw it on, and then we just read off the coordinates where those two lines intersect. So we're looking at, and there'll always be a little bit of an error for this one, so I'm looking at roughly, it looks like 0.75 minus 0.75, sorry, and 2.75. Let's say x is equal to. And there'll be a bound, sort of an interval that is acceptable. Let me just bring up the mark scheme and have a look. Right, so they say anything between minus 0.65 up to minus 0.6, or the other way around actually, and 2.65 up to 2.8. So yeah, we're well in the middle with both of those. Not what, well, we're in the middle with both of those. Question 8. In a bag there are only red counters, blue counters, green counters and pink counters. A counter is going to be taken at random from the bag. The table shows the probability of taking a red counter or a blue counter. The probability of taking a green counter is 0.2 more than the probability of taking a pink counter. Complete the table. So let's just look at that. So the probability of taking a green is 0.2 more than the probability of taking a pink counter. So let's go green and pink. So if we call pink x, then green would be x plus 0.2. And all of those probabilities need to add up to 1. So 2x plus 0.05 plus 0.15 is going to be 0.2 plus 0.2. So, and it would help if we added that into a calculator mode. So we'll do it without. That adds up to 0.2 plus another 0.2 is going to be 0.4. And that's got to be equal to 1, so 2x has got to be equal to 0.6, so x has got to be equal to 0.3, and then we've got 0.3 here, and 0.5 here. There are 18 blue counters in the bag. Work out the total number of counters in the bag. So we just do 18 divided by 0.15. Again, let's actually go into the calculator mode this time. Gives us 120. Not the only way you can do it, probably the quickest way on a calculator paper though. Question 9, use your calculator to work out. I'm just going to make that a bit smaller now because it's starting to irritate me. Right, so on these calculators we can type it in just like that. Just checking my eyes are working well. 29 squared, definitely squared, minus 4.6 divided by the square root, and the square root does that over the whole of this denominator, and we've got 35 minus 1.9 cubed. Double check that we've typed everything in right, and I believe we've got a decimal point wrong there. Everything else looks fine. Double check it though. That gives us 157. Write down all the figures on your calculator display. So 157.668255. And then we normally have a rounding part, correct to 4 significant figures. So that's the 4th significant figure. The number behind it is a 6, so we'd round it up. So it becomes 157.7. Question 10, expand. Whatever method you use for expanding is absolutely fine. I tend to use the construction line or the grid depending on who I'm showing. So I'd say x times x gives me x squared. X times minus 9 would give me minus 9x. 5 times x would give me 5x. And then 5 times minus 9 would give me minus 45. and then collect my middle terms. So we're going to have x squared minus 9 plus 5 would give us minus 4 minus 45. And then for our fully factorised, so we need to find our highest common factor of 9x squared and 6x, which is going to be 3x. And then to get 9x squared, we need to times 3x by 3x. And then to get 6x, we need to times it by 2. And that's our fully factorised. Question 11. Here's the graph of, write down the y-intercept. The y-intercept. So the y-intercept where is looking like 4. So y-intercept would be 4. Write down the coordinate of the turning point. So that's where the gradient changes, or where so it's going to be that point there. That's where the graph turns. So we are looking at 3 minus 5. And then write down an estimate for, and again, like the one that we did earlier, we're comparing this equation with y is equal to 0. So we're looking at this coordinate here and here. So x would be equal to 0.75 and 5.25. And again, the mark scheme says, let me have a look, anything between 5.1 and 5.3, so yeah, we're within there, and anything between 0.7 and 0.9, do actually say 0.75, I only write 0.7. Question 12. Given that the function of x is equal to 4 sine x, find f of 23, giving the answer to 3 significant figures. Well, so the f of 23 is going to be equal to 4 sine 23. So 4, calculate in degree mode, it is. 4 times by sine of 23 gives us the value of 1.56. So as for 3 significant figures, I always have a habit of writing it more accurate than is asked for in the question. So put some dots in to imply that you've not rounded, and then round it to the accuracy you asked for. 3 significant figures, we're rounding to that 6, so it'd be 1.56. Right, the g of x is equal to 2x minus 3. Find f of g of 34, given your answer to 3 significant figures. Okay, so the most straightforward way of doing this is to work out g of x first of all. So the g of 34 is going to be equal to 2 times 34 minus 3, which is going to be equal to 2 times by 34 minus 3. That's going to be 65. And then we are going to place that into, so we're going to say that the f of the answer that we just worked out is going to be equal to 4 sine times that answer. So that's going to be 4 times sine of the answer. So 3, and again we'll go more accurate, 3.62523 ... and then we round it to 3 significant figures, so that's going to be 3.63. Ivan needs to solve the following equation: h of x is equal to 25. He writes x plus 4 squared is equal to 25, x plus 4 is equal to 25, is equal to 5, x is equal to 1. This is not fully correct. Explain why. So the square root of 25, it's technically feel like. Anybody going on to A level might not like that. But the square root of 25 is actually equal to plus or minus 5. So he has missed out a solution with minus 5 as the square root of x plus 4 squared. Technically that's more mathematically correct, but there we go. Question 13, use these graphs to solve the simultaneous equation. So if we've got them graphically, just double check that we've got the two graphs of the same two equations. We're just looking for the intersection. So the intersection is at the coordinate minus 2, 4. So that's where x is equal to minus 2 and y is equal to 4. And use your graph to estimate the solution of, and again, questions appear, similar questions appeared a few times. So we're taking off these coordinates. So x is equal to, this time we're looking at 0.6 and x is equal to 3.4. And again, there will be some range of acceptable answers. So Martin says 0.55 to 0.65 and 3.35 up to 3.45. Yeah, so we're slap bang in the middle with both of those. Let's just move that back. I'm trying to flick it page up with my finger. Okay, question 14. Sakira invests £3,550 of in a savings account for 3 years. She was paid 2.6% per annum compound interest for the first 2 years. She was paid R% interest for the third year. Sakira has £3,819.21 in her savings account at the end of the 3 years. Work out the value of R, giving your answer correct to 1 decimal place. Right, I'm going to replace this with x for now, and I'll fully explain why. So I'm going to treat it as a multiplier and then convert it back into an interest. So I'm going to say that if we take the initial investment of £3,550 and we times it by compound interest for 2 years would be a multiplier of 1.026. 1.026. So times by 1.026 squared for the 2 years times by x, and that's got to be equal to £3,819.21. So I'm going to jump straight to x. I'm going to say that is, and I'll type it in as a fraction, save me having multiple working lines, £3,819.21, and I'm going to divide that by, just double checking I've typed that in right, divided by £3,550 times by 1.026 squared. So that is our value for x, which remember isn't our value for r. So we actually want, so r is going to be equal to this times by 100 and then take away 1, but it's going to be equal to 2.1998, so to 3 decimal places, 1, 2, 3, that's a bit slightly an awkward one, that would be, oh sorry, to 1 decimal place, where did I get 3? 3. To 1 decimal place, that's going to be 2.2. Question 15, here are some graphs. Okay, in the table below, match the equation to the letter of the graph. So the sine curve is a constant wave, but sine curve, so we've got our constant waves D and E, D and C. The sine curve starts at 0 though, so that would have to be a graph C. Right, positive cubic, so that's going to be a wave. So that's going to be F. An exponential, positive exponential, so that's going to be A. And then a reciprocal graph, a positive reciprocal graph, which is going to be H. Question 16. A pet shop has 7 guppy fish, 13 tetrafish, 5 angelfish. David's going to choose one of the following combinations of fish: a guppy fish and an angelfish, or a tetrafish and an angelfish, or a guppy fish, a tetrafish, and an angelfish. Show that there are 555 ways that David can choose a fish. Right, so for this, we'll do them separately. So a guppy fish or an angelfish, that is going to be number of ways that can happen would be 7 times 5. The number of ways that we can make the second choice, tetrafish and an angelfish, tetrafish, 13 times 5 times 5. And then the final combination, guppy, so that's going to be guppy tetra angel, that's going to be 7 times 13 times 5. So 7 times 5 plus 13 times 5 plus 7 times 13 times 5, and then all being well, that should be 555. No, because we've, for some reason, typed answer instead of 7, so let's redo that. 555. There we go. And 17. Seja works at a weather station. The table gives information about temperature, T degrees C on midday of each of the 50 cities in the UK on Tuesday. Calculate an estimate for the mean temperature. So for that, we need to multiply midpoints of each group. That's not right. So the middle of that would be 12.5. Middle of that would be 17.5. Middle of that would be 22.5. Middle of that would be 27.5, and then 32.5. And then we times that by the frequencies, and then we add them up. So 12.5 times by 2 plus 17.5 times by, this is my decimal point out, times by 8 plus 22.5 times by 13 plus 27.5 times by 21 plus 32.5 times by 6. Double check that we typed everything in right. So 12.5 times by 2, check. 17.5 times by 8, check. 22.5 times by 13, yep. 27.5 times by 21, and 32.5 times by 6. Okay, so that gives us 1,230. So our estimate for the mean would be 1,230 divided by the number, which is 50. So we're looking at 24.6 degrees C. So 24.6. I've lost that right in 24.6. Right. So the median temperature is 22.5 because 22.5 is the middle number in the middle group. give a reason for your answer. No, that's not the correct way for working out the median. If we do, so, right, to work out the median of 25, we would need to do 50 plus 1. I should do this in a different colour pen really to show that I'm on part B. And I'll do it in the right space. 50 plus 1 divided by 2 would be equal to 25.5. So we'd need to find the 25th and the 26th position. So far we've got 10 that are 20 or smaller. We've got 23 that are that or smaller. So the median would be in that group there. So no, she has used an incorrect method. The median would be in the 25 to 30 group. Let me just move that word back up. There we go. On the grid, draw the graph of x squared plus y squared equals 12.25. So an equation of a circle around the origin would be x squared plus y squared equals r squared. So we want the square root of that, so we can plot our coordinates. So 12.25 square rooted is 3.5. So that looks quite small though, to be fair. And not very nice, because the graph is not the greatest of axes for this. So in effect, I'm plotting 3.5 on all quadrants. And then I just need to join them up with this a circle. You could obviously use your protractor for this. I'm going to try and insert a circle though. Right, this is going to look terrible to start with. Right, I'm just going to format the shape slightly. There we go. I don't think that's the best set of axes for that question, but there we go. Right, part B, hence find an estimate for the solution of, and then we're given our equation. So we need to plot this line, 2x plus y is equal to 1. So I'm going to take, could rearrange that to say y is equal to minus 2x plus 1. Then we've got the gradient of minus a half and the intercept of 1. I'm going to take a slightly different approach. If these two numbers add up to 1, then when x is 0, y would be equal to 1. So that's going to have to be a point on there. And then when y is equal to 0, y would be equal to a half. Right, so let me just extend that line a little bit. confusing myself with my axes slightly. Right, so that's my second line. So if I insert a line to represent that, just move it around till I'm happy with it. Right, and then I want to find the 2 points of intersection between the two lines. There and there. So reading the coordinates off, then I'm going to have two pairs when x is just trying to read it off. Just below 2, but only just. So let's go when x is equal to 1.95, 1.95, and y is equal to minus 2.95. So I think actually 2 and minus 3 would be fine there. And then the next one we're looking at is minus 1.05, maybe slightly more than that, minus 1.2. X is equal to minus 1.2, and y is equal to what we 3.3-ish. So those are my two pairs of values. Question 19, the vectors A and B are shown on the grid below. On the grid, draw and label minus 2A. Work at A plus 2B as a column vector. So minus 2A doesn't give a starting point. So if I start there, so that's twice as big as A, but I need to have it going in the opposite direction. Work at A plus 2B as a column vector. So if I put those as column vectors, so A would be 1, 2, and plus 2 lots of B, which is 1 minus 3. Then A plus 2B becomes 1 plus 2, so that would be 3. And then 2 plus minus 6, so minus 4. Question 19, show that complicated algebraic fraction or sum simplifies to, okay, so it looks complicated. I'm going to take this in stages though. The first thing I'm going to do is I'm going to factorise the top line. So 6. So break it down into steps. So 6 plus x plus 5 divided by, and then if we factorise the top line, two brackets starting with x, two numbers that multiply together to make minus 10 and add together to make 3 are going to be 5 and minus 2. Divided by x minus 1. Right, dividing by any fraction has the effect of multiplying by the reciprocal. So if I should have left myself a bit more working space here. 6 plus x plus 5 times by, put that in brackets for now, x minus 1 divided by x plus 5 times by x minus 2. Now those parts cancel out. And what I'm going to do is put the 6 as a fraction over x minus 2. So I'm going to put the whole thing over x minus 2. And then to do that, I times this by x minus 2. So that would be 6 x minus 2. Plus x minus 1. And we'll take that, actually we'll just go across. So that gives us 6x plus x would be 7x. Minus 12 minus 1 would be minus 13 over x minus 2. And there we go. That's simplify, and that's it. So A is 7, B is minus 13, C is 1, and D would be minus 2. Right, question 21. Find the ratio of C to D. Okay, so the first thing I'm going to do is take all the terms over to the same sides. So if I minus C and minus D from both sides, that would give me 4C is equal to 3D. And I've miswritten X instead of C. Some people are absolutely fine going with a ratio straight for that. But by experience, I know that that's going to be 3 to 4. I'm not great at doing that. I often view if you have ratio of C to D is equal to, let's say, A to B, then C over D is going to be equal to A over B. That's just kind of how it works. So I tend to find it easier to explain in terms of putting it as C over D. So I would say that C over D equals 3 over 4. So the ratio would be 3 to 4. Right. I lost my 4. Right, okay, so I'm going to take everything over to the left. That should be a squared, by the way. So it's obviously formatted not correctly. Hopefully you've spotted that though. So x squared minus 7xy minus 20y squared is equal to 0. Right, I'm going to try and factorise this now. So I'm going to treat it, just trying to think whether this is an acceptable method to show. So I can factorise this in terms of and it holds true that you'd factorise in the same method. That's not necessarily the most straightforward way to view if you're not used to factorising in terms of two parts of algebra. So I'm going to do it that way. So It's either got to be a 6 and a 1 or a 3 and a 2. I'm going to go for trying a 3 and a 2 to start with. So then I'm still after two numbers that multiply together to make 20. And three lots of one of the numbers plus the other number, sorry, minus 20, add together to make minus 7. So let's think about numbers that could work. 5 and 4 would be the nicest. 5, 15, 12. Yeah, that would work. Would it? 15. So let's just try 5 and 4. One of them's got to be negative. 5, 4. Does that pair work? Minus 15 plus 8. Yeah, that works. Minus 15 plus 8. So the minus 5 goes here, and the plus 2 goes here. Right. That will give us two values for x. First, for two things to multiply together to make 0, one of the values has to be 0. So I'm going to keep it as x. So either x is, let's do this to the side. So either x is equal to minus 2 over 3, or x is equal to 2 over 3y, or x is equal to 5 over 2y. And it says here that x has got to be greater than 0, so it can't be that value, so it has to be this one. So like I did before, x over y would be equal to 5 over 2, so the ratio of x to y would be 5 to 2. And that's typically how I would do this. I think this is quite a really tricky question to have on a foundation, on a higher tier. I would possibly consider substituting, dividing through by y squared here. No, dividing through by y squared, and then creating another unknown. Instead of calling it x and y, you could create it as p. But I think that's a bit of a complicated method as well. So that's the way I would do it. But I think it's quite a difficult one to have on a higher tier question. I think that's a real complicated question. Right, question 22. Karina has 4 tanks on her tractor. Each tank is a cylinder with a diameter of 80 centimeters and a height of 160 centimeters. The 4 tanks are filled completely with a mixture of fertilizer and water. The fertilizer has to be mixed with water in a ratio of 1 to 100 by volume. Karina has 32 litres of fertilizer. 1 litre is 1,000 centimeters cubed. Has Karina enough fertilizer for the 4 tanks? So I'm going to work out the volume that she needs to be able to fill to start with. Just scanning the question again, is that the most easiest way of doing it? Yeah, I'm going to do it that way. So the volume of a cylinder is equal to pi r squared h. So we actually want the volume of 4. So 4 times the volume is going to be equal to 4 lots of pi times by, the radius would be 40 squared times by 160. I'm going to leave my answer in terms of pi for now. So shift pi, so 4 times by pi times by 40 squared times by 160. So large number. So 1024,000 pi is the volume that she has to be able to fill. Then we've got fertilizer to water. So fertilizer to water is in the 1 to 100. She's got 30 litres of fertilizer, so she's got 32 times by 1000. So she has got 32,000 litres. So she would be able to, she would need 32, 2, 3, 4, 5 centimeters cubed. So she has got enough for 32,300. So 30. Let me write the number and then try and pronounce it. So she's got 3 million. She's got enough fertilizer to make 3,232,000 litres. So let's just work this out then. So if we times that by pi, we would have so she needs 3,216,990.877 centimeters cubed, and she has more. So let's put just needs and then has. So does she have enough? Yes, she does. Yes. As 3,216,990.877 is less than 3,232,000 centimeters cubed. Right, question 23. Alan grew 80 plants of the same type outside. The cumulative frequency graph shows information about the heights in centimetres of these plants. One of the plants is chosen at random. Find an estimate for the probability that the plant will have a height greater than 90 centimetres. Right, so I'm going to go at 90 centimetres, which would be these going up in threes. Right, so that's not particularly easy, so that's so I'm making that, so this is going up in 10, so 70 to 4, somewhere between 74 and 75. So we'll go 75, so 80 minus 75 is 5, so we're looking at 5 over 80. So 5 over 80, which would be 1 over 16. And the mark scheme says we can accept 5 or 6. So 6 over 80 or 5 over 80. Just double check. Yeah. Use the graph for an estimate for the median height. So from a cumulative frequency, we take the median as 40. So if it's 80, we take them. So we go 40, we go across, and we read down. Now each of these are going up in threes. No, they're not. They're going up in 2.5s. Right. Yeah, I probably should have gone for 6 there. That's not a problem though. So we're looking at 4 times 2.5 is 10, so we're looking at 60 centimeters. And then is the estimate for the interquartile range of the heights. Okay, so for the interquartile range, I need this value here, and I need this value here. So I'm going to do 75 minus, well, like I said, these are 2.5, so that would be minus 40. So that would be 35. Ooh. Just trying to highlight that. I wanted all of that down. Individually. One more bit. Right, so we're looking at 40. Okay. Right, let's undo that. There we go. Sorry about that. Okay, so Alan also grew plants of the same type inside. The interquartile range for these plants was 30 centimeters. Give one comparison between the distribution of heights of the plants grown inside with the distribution of plants grown outside. So the interquartile range for plants outside is larger. So the interquartile range is larger for plants grown outside. So their heights is more varied. Question 24, solve. So another algebraic fractions. I'm going to start by multiplying by these two parts of the denominators. So in effect, I'm timesing by x plus 4, 2 minus 2x on both sides. So that would give me, and so that would give me 1 times by this. So it would give me 2 minus 2x plus this fraction would give me 3 lots of x plus 4, and that's going to be equal to x plus 4 times by 2 minus 2x. Right, if we multiply both pairs of brackets then, that would give me 2 minus 2x plus 3x plus 12, and that would be equal to 2x minus 2x squared plus 8 minus 8x. Just double checking what I've done here. 2x minus 2x squared plus 8 minus 8. Yep. Could have taken 2 out as a factor, but not to worry. Right, so let's tidy up this side now. So our number part, well, we'll do, so that's going to be x plus 14 is going to be equal to minus 2x squared to minus 6x plus 8. I'm going to take everything over to the left-hand side now. So that would give me 2x squared plus 7x plus 6 is equal to 0. And if I factorise that, then it's got to be a 2x and an x. Two numbers that multiply together to make 6 and add together to make 7, where one of them is a 2, would have to be 2 and 3. 2 there, 3 there. Plus and a plus. So either x is equal to minus 2 or x is equal to minus 3 over 2. So x is equal to minus 2 or x is equal to minus 3 over 2. Question 25. RS and ST are two sides of a regular 12-sided polygon. RT is the diagonal of the polygon. Work out the size of STR. You must show your working. So ST to R, so I want that angle there. Okay, so I'm going to first of all work out the exterior angle. So that's going to be 360 divided by 12. So that's going to be 30 degrees, which means that RST must be equal to 180 minus 30. So that's going to be 150. So STR must be equal to I've done a step more than I needed. 180 minus 150 divided by 2, so it would be equal to 15 degrees. You must show your working. There we go. And question 26, the graph below says gives the volume in litres of water in a container t seconds after the water starts to fill the container. Calculate an estimate for the gradient when the time is equal to 17.5. You must show how you get your answer. So 17.5 is going to be this point here. Right, I want to add a tangent then, so I'm going to do that using a straight line. Right, I want to just touch at that point. That looks pretty good. Okay, so I need to work out the gradient of that then. So that's going to be the change in y. And I'm going to take a nice largish circle here. So the change in gradient is 17.5. Change in 17.5. Over the change in x, which is going to be 5, 10, 15, and then that looks like 2, 4, 6, 8, 8 over 17. So that's 17. So the gradient is going to be 17.5 divided by 17. So 17.5 divided by 17 gives us 1.029, 1.029 for 1 dot dot dot. So we'll go 1.0 2. Right, and there'll be a bound of error on the mark scheme for that, and I am just on the bound, so my tangent's obviously not great. 10, 15. Maybe this should have been. So the range of error on that is 0.9 up to 1.2. Oh no, so I'm pretty much close to the middle. Okay, yeah, I thought I misread. 1.2 is 1.02. Describe fully what the gradient in part A represents. So it is the rate at which the volume increases. Let's just clarify. Volume of water in container. So it's the amount of litres. The rate of, so it is the rate at which the volume increases. So so it's in effect how many litres per second the tank is increasing by. The water in the tank is increasing by. The water. The water in the tank is increasing by. Question 26. Curve C has equation. The line L has equation. Show algebraic that C and L have exactly 1 point in common. Right, so if I rearrange this equation first of all, that gives you y is equal to 5x minus 4. And if I put these two equations equal, that means x squared plus 3x minus 3 is equal to 5x minus 4. Now if I take everything over to the left, that would give us x squared minus 2x minus 7. No, what am I talking about? Plus 4. So plus 1 is equal to 0. And then if I factorise that, that's a square. So x minus 1 all squared is equal to 0. So x only has one value, so x is equal to 1, which is a repeated root. So that means that in effect it's where it touches. So one solution. So 1 point in common. Should we give the coordinate? which would be 1, 1. I don't think we particularly need that then. Question 28. Time period t seconds for a simple pendulum of length L is given by the formula. Kate uses a simple pendulum in an experiment to find an estimate for the value of G. Here are her results. L was 5.2.0, correct to 3 significant figures. T is 1.45, correct to 3 significant figures. Work out the upper bound and the lower bound of G. Use pi is equal to 3.142. Okay. We shall do that rather than the pi button. So the first thing I'm going to do is rearrange that. So, because it's a G that I'm trying to work out. So, I'm going to say that T over 2 pi is equal to the square root of L over G. Square both sides. So, T over 2 pi squared is going to be equal to L over G. So G is going to be equal to L times 2 pi squared over T squared. Right, if I start with upper and lower bounds then, so L correct to 3 significant figures means that we've got 51.95 and 52.05, and for T we've got 1.445 and 1.455. Right, so if we want the upper bound, I'm going to, so upper bound first. So the G max is going to be equal to the maximum for L, so I'm going to go L max times by, let's just say 4 times by L max times by pi squared, divided by the minimum for this, so T min squared. And we'll go for the G minimum is going to be equal to 4 times by the L minimum times by pi squared divided by T times T max squared. Right, so I'm going to go straight to my upper bound now. So I'm looking at 4 times by 52.05 times by, remember to use that value for pi, 3.142 squared. And I want to divide that by the time minimum, so 1.445 squared. So that gives me my maximum value of 984 point, it doesn't really say to, we'll go 3, 6, 7, 7. Trying to work out how accurate to go. Does the question give us an indication? Doesn't really. So I'll go without rounding 984.36778 ... and then we'll go to 3 decimal places. Right, and my minimum value, I'll type it in as 1 this time, 4 times by the minimum value here. And 95 times by 3.142 squared divided by max 1.455 squared. Is 969.0181 ... So same, 969.018. Question 29. Show that can be written as that. So straight away this gives me an indication that we're using the iterative formula, and the bit that we're going to make not standard iteration one. Right. Okay, so the way that they've done this is an interesting one. So if I take my minus 5 over to the other side, that would give me x cubed plus 7x is equal to 5. If I then factorise, that would give me x times by x squared plus 7 is equal to 5. And then if I divide by this, that gives me x is equal to 5 over x squared plus 7. This is what we were asked to show. I've missed part A out. Oh, okay. So apologies, I missed part A out. Rewinding then, part A. Show that it has a solution between 0 and 1. Okay, so we just need to say 0 cubed plus 7 times 0 minus 5 is minus 5, which is greater than 0. So that is greater than 0. Sorry, less than 0. And then when x is 1, 1 cubed plus 7x minus 5 is going to become 1 plus 7 minus 5, 8. So that's going to be 3, which is greater than 0. So solution is between 0, x is 0, and x is equal to 1. Right, starting with x is equal to 0, use it 3 times. So we've got x equals 0 is equal to, start to flag a bit. Right. So x0 is equal to 1. So x of 1 is equal to first time, second time, third time. Right. So I'm going to go starting with 1. Okay, so I'm going to go 1 equals. Then I'm going to type in 5 over answer squared plus 7. Then equals. So 1 equals. I'm then going to type it in as a fraction with 5 as my numerator, and then the answer squared plus 7. And then my first value is 5 over 8. My second value is 320 over 473. And my third value is 0.670448. It does actually say an estimate. So really, I want that as a digit. So let's do that. Point. So 320 divided by 473. 0.676. So we will say, I'm debating my degree of accuracy here because when you get to A level, you carry on with this iterative process until we get repeating pattern, and we haven't really got one other than the first digit. So arguably it's 0.7, which isn't very good. We'll go a bit more accurate than that though. So 0.670 to. Let's just check the mark scheme. What does it say? They're arguing for another decimal point. Okay. Part D, by substituting your answer to part C into this, comment on the accuracy of your estimate of the solution. Okay, so if we take this answer, we've still got it here, so we do answer cubed plus 7 times the answer minus 5 equals 0.04537. Comment on the accuracy of your answer. So we're very close. So we are very close to 0. So is accurate. Right, question 30. Diagram shows part of the graph of blah blah blah. By drawing a straight line, use the graph to estimate the solution of. Great. So we are comparing y is equal to x squared minus 2x plus 3, and we are comparing it to the solution of x squared minus 3x minus 1 is equal to 0. So I want to kind of rearrange this equation to get this. So to do that, I would need to add x and add 4 onto both sides. So x squared minus 2x plus 3 is equal to x plus 4. So let's just show that I've added plus x plus 4. So I want to draw the line of y is equal to x plus 4 and find where the two lines intersect. So we've got an intersect of 4, and then for every 1 across it goes up 1, so for every 2 across it goes up 2. So we want to find where those two lines intersect. So and we only really want the x coordinates, so x is equal to, those are going down in 0.2, so minus 0.4, and x is equal to 3.4. P is the point on the graph, y is equal to, where x is equal to 2. So this is again going to be tangent. Calculate an estimate for the gradient. Right. So want to put a straight line in again. That looks okay. Let's extend that line a bit. And let's look for a triangle to take then. Just looking for a nice one, but I can't really find one. So let's go from there to there is 4, 6, 5, 5.4, and from there to there is 10.4. So we're looking at 10.4 divided by 5.4. So we're looking at 1.925. So let's go to two decimal places, 1.93. And let's quickly check the mark scheme. Should have done that for the last part as well. So for up here, anything between minus 0.4 to minus 0.2 was acceptable. So we are on the range rather than inside. And then for the other one, 3.2 and 4.2. 3.2 up to 3.4. So again, we're close to the range on both, but within. Calculate our estimate. We get 1.93, and we're allowed to accept anything from 1.6 to 2.5. So pretty close to the centre of that. Right. Slightly on the lower end, but not by much. Ollie drove 56 kilometres from Liverpool to Manchester. He then drove 61 from Manchester to Sheffield. Ollie's average speed from Liverpool to Manchester was 70 kilometres per hour. Ollie took 75 minutes to drive from Manchester to Sheffield. Work out Ollie's average speed for the total drive from Liverpool to Sheffield. Right, so I'm going to call this part 1 and this part 2. So I'm going to go, I always find these compound measures questions easier to do with a little table. So speed, distance, time. Right, the bits that we know. Part 1 of the journey was Liverpool to Manchester, which was 56 kilometres, 56 km. Then drove 61. Part 2 was 61 kilometres. Average speed from Liverpool to Manchester, that's part 1, was 70 kilometres per hour. Ollie took 75 minutes to drive from Manchester to Sheffield. 75 minutes is an hour and 15, so 1.25 hours. 1.25 hours. Right, work out Ollie's average speed for the total. So I've messed up my heading slightly. That's a distance, that's speed. Average speed, so this is our goal. Right, we can work out the total distance straight away by adding these two values together. So 56 plus 61 is going to be 117 kilometres. We really want the total time next. So the total time is, if we work out the speed is equal to distance divided by time. So time is equal to Distance divided by speed. So 56 divided by 70 is 4/5 of an hour, which is 0.8. So the total time is going to be 2.05. And then speed is equal to distance divided by time. So we want to do speed is equal to 117 divided by 2.05. So 117 divided by 2.05 gives us 57.0731 ... So give us, we'll go 57.1. Okay, Gianni drove from Barnsley to York, and his average speed from Barnsley to Leeds was 80 kilometres per hour. Her average speed from Leeds to York was 60 kilometres per hour. Yanni says the average speed from Barnsley to York can be found by working out the mean of them. If Yanni is correct, what does this tell you about the two parts of Yanni's journey? So there are two acceptable answers here. The first one is that the time taken for the two parts of the journeys must be the same. So time taken is the same for both parts. The other option is the distances, so 60 over 80, 3 over 4. So the other option is that the distance from Leeds to York must be 3/4 of the distance from Barnsley to Leeds. So Leeds to York is 3/4 distance of Barnsley to York, Barnsley to Leeds. Okay, and final question. ABC is a triangle. Point D is on the point of BC such that angle BAD is equal to angle DAC, which is equal to X. Okay, prove that. AB over BD, AB over BD is equal to AC over DC. Right, I'm going to start by just, so we want to prove that, I'm just highlighting the lines that I'm using, AB, AC, BD, DC. Okay, that's not too bad because actually that's a common side to both of the triangles. Right. So I'm going to start by saying that BD over sine X is equal to BD over that is going to be equal to AB over the sine of ADB. And I'm also going to work on a similar process and say that DC over sine X has to be equal to AC over the sine of ADC. Right. I'm kind of going to use this to explain my next process. That's going to be y, and that's going to be 180 minus y. And then if I think about the sine curve Okay, so if we think about this, if I call that distance there x, that distance there would be x. Sorry, I should have called that y. So the sine of y must be equal to the sine of 180 minus y. So these would both be equal. So sine of ADB must be equal to the sine of ADC. Right, so I can rearrange these now and say that, and I'm not actually, these might not actually work out. Let's rearrange it to look like this. So the sine of ADB over the sine of x must be equal to AB over BD. And then for this one, if I rearrange it and into a similar process, and I'm going to call this the sine of, instead of ADB, I'm going to call it ADC, I'm going to call it ADB because it would be the same. So the sine of ADB over sine x must be equal to AC over DC. So all these parts are equal. So AB over BD must be equal to AC over DC. And there we go. Okay. And that brings us to the end of the paper. Right. Okay, so that brings us to the end of the paper. Hope you found that useful. Just before I sign off, so I said at the start of the video about how I used Edexcel's Enhanced Skills mapping document to compile this paper. Just if it's useful to anyone, if anyone particularly wants rough grade boundaries, it kind of generates them for me. I'm not overly convinced that these are particularly accurate, but based on past data, based on the data, it suggests roughly that on that paper you needed 23 marks for a grade 4, 32 for a 5, 39 for a 6, 48 for a 7, 58 for an 8 and 66 for a 9. So it was a really good, solid paper. Thank you very much for your time in watching, listening, however you want to phrase it. Once again, big shout out to First Class Maths for compiling the data that I derived these questions from. Check out their website. They're going to be releasing paper 2H as well. Thank you very much for your time in watching. Good luck with the rest of your revision. I would strongly recommend, if you haven't already done it, to have a good look at the highly likely paper as well as this one. Good luck with your exam as it comes up, and if you found this useful, please do subscribe if you like.